Okay, a few weeks ago we were in the classroom. We discussed how to do a multi-pass weld. The purpose of a multi-pass weld is to properly tie welds together. I have found in the years I've been teaching and through the years that I worked that welds that are not tied together properly on a piece of equipment or whatever it is that you're building where multi-pass is required, if it's not done correctly, the welds can fail and the part can break. Then you have to call back out to redo the job. Just to go over right here before we actually go to the plate, we're going to be using a 6x6 plate, and then we're going to run a single weld, clean the slag, then we're going to run 3 other welds showing how to do the multi-pass and tie together correctly. But you can see here, this is just, it would be an in view of the plate. Here would be the first weld. I'm drawing these large so we can get a good detail of what's going on. Now, if we're looking at the end plate, I'm not going to be able to show travel angle here, but I will be able to show work angle. Work angle is simply how the welding rod is placed in relation to the metal. Now, if I'm traveling this way, let's just imagine the plate come off here. If we're coming this way, my work angle should be at 90 degrees. That way we lay down the weld correctly. Once we do that weld, we clean it, brush it. Then our welding rod will come over here. There's a little leeway for your work angle here. Somewhere between, I'm gonna say somewhere between 75, 65 degrees, depending upon how you weld. Everyone is a little bit different. What you want to do, this right here, if you remember, is called the toe of the weld, where the weld meets the metal. So what we want to do with our next weld is our welding rod should come down and the center of the welding rod should cover the toe of the weld. We will come down the toe of that weld the whole time, and that should push the weld halfway up. We will clean this weld, then we'll repeat the process with the same angle, covering half the weld. Clean it, then we will repeat the process again. So when you're done, and this is cool, you should be able to take your hand across the top of these welds and they should be pretty smooth. The reason I don't suggest doing bigger welds is because of heat affected zone. Multi-pass is proven to be a lot stronger for the fact that you don't overheat the metal per pass. That's another story. We'll talk about that in metallurgy. But we're going to be using a 1/8 welding rod. General rule is your weld should be 2 to 2.5 times the diameter of the rod. So we should end up with a 1/4 to 5/16 weld. So that's what we should end up with. Now let's go over here and look at the welder and just talk about the setup of the welder for just a minute. Okay. As you know, most welders are different. No welders are going to be the same. These small Miller welders that I have here, they have 2 settings. We can change to AC or DC current. 7018 welding rod is what most people use. We can use DC positive, meaning the electrode is positive, DCEP. Here would be how you would switch these over from the polarity from DC positive to DC negative. And if you wanted to go to AC current, you would move them to here. So now this welder has a high side and a low side. The differences are subtle between the two. I like the low side for flat welding. I like the high side for vertical welding. Vertical, I seem to have a little better arc stability on the high side. But since we're on the low side, we're going to be on the blue line. The inside numbers associated with that blue line, we're going to weld somewhere between 100 and 120 ounce. That's my recommendation. Other people weld a little different. My recommendation for flat welding though is 1 100 to 120 amps. Okay, so my welder is set. I would turn it on, which I'm just not going to for demonstration purposes. The welder is set and everything. So, if you'll notice, I have my gloves, I have my clear glasses, and I have my welding hood, I have my long shirt, pants, and my boots on. PPE must be worn at all times in order to be safe. Does anybody have any questions so far? Good. Good. Okay. So, once I get ready to weld, I'm going to go ahead and put my glasses and gloves on. Then, I am going to take these back off because it's easier for demonstration purposes. Now, I want to talk about how to put the welding rod into the stinger, electrode stinger. If you'll notice, there are several things here in the jaws of the stinger which allow you to place the welding rod in there differently. A lot of people will place the welding rod in here like this. You can see that it's at a 90-degree angle. You can either do it that way. You can put the release on your thumb side. I personally like it on my finger side. Also, you can put the welding rod in here at an angle. Now, if you look, this would be considered, going this way, my travel angle. So, I prefer to put the welding rod in there that way and hold this horizontal level to what I'm working on. That keeps my travel angle correct. Now that we know what our travel angle should be, which is somewhere between 75 and 65 degrees, or if you look at it another way, 15 to 25. So what you'll do then is on your first weld, your welder's turned on, you strike your arc. If you'll notice, my welding rod is at, if you measured, it would be 90 degrees on both sides. You're going to run your bead continuously down through here. And the whole time, this welding rod is going to be consumed. As this welding rod is consumed, I want to simulate what it looks like. As it's consumed, first-time welders have a tendency to want to do this. If I do that, I've changed my travel angle. So what I suggest is, as you weld, you just allow your hands to drop. You may have to bring forward some to keep the rod, keep the weld size correct, I'm sorry. So what I suggest is that you drop your hands as the rod burns off. Now, there are different theories and there are different practices on this. I'm going to put my safety glasses back on for this next thing. A lot of people want to touch the welding rod to the metal and make the weld that way. If you do that, I suggest you run a little higher heat. Technically, our RT Miller Weld Skills book suggests that we run an arc gap, the diameter of the welding rod, which is 1/8 of an inch. I run about 1/16 to 1/8. Stabilize yourself, and then you run your weld down through there. You don't want to get too long. If you do, it's just going to splatter everywhere. You'll get a lot of contamination. If you drive the welding rod into the metal, possibility of it sticking, then you have to stop, clean, start back over. So, I've made my weld. Now, I've made my first weld running the proper angle. I'm going to take my chip and hammer. I have my gloves removed. This metal is cool. I've done this earlier. Normally I would have my gloves on. You don't have to beat. A lot of people want to just beat the fire out of it. You don't have to do that. If you'll notice how I'm at the edge of the slag, it comes off. Take your wire brush, clean it. Now, to show how to do the next weld. This one was the first weld done with the rod work angle at 90 degrees, approximately 75-degree travel angle. The next weld I would make, I would come in here and I would actually bring the rod and I would lay it over. Now this can vary depending upon weld height, heat settings. But the key to getting a good multi-pass weld is staying right in the toe of the previous weld. As you come down through here, remember to keep your travel angle the same. As the rod consumes, you got to bring your hands down. But you run your weld right down the toe of the weld. Once you do that, you chip and clean. You repeat this process until you have the size weld desired. Now, your project will be to take this plate and do 4 welds properly tied together. I have an example here of the first weld and of the 4 welds. It may be a little hard to see, but I'm going to do my best to show you. You can see this was my first weld right here. You can see how this weld really overlaps well, okay, all the way down through here. I got a little close here on the bottom where I finished. I cleaned and then I done the next weld. But you can see these are really smooth together. So multi-pass is very important when it comes to strength. I went just toward the factory at Wayne Supply in Louisville whenever I was at the skills competition. A lot of their welds on their buckets, on loaders, and some of the welds on the dozer blades, they were all multi-pass. Now, if you're somewhere where you're required to do a single pass and have a weld that's a 1/2 inch, you go to a 3/16 to 1/4 inch welding line. I don't suggest a big weave for the purposes of putting too much heat into the metal and possibility of trapping slag within the weld. Does anyone have any questions before we do this project?
Good to go.
Okay, get started.